Hi guys. So for these
Welcome
problems,
back to my YouTube channel.
it's not funny, Gianna. Anyway, so for these problems, you have to split up the three vectors into lines that can be broken up and add into resultant. So we learned that like if you go east in a straight direction and you go west in a straight direction, they can cancel out. And if you go up in a straight direction, or north and south in straight direction, they can also cancel out if they're the same units. So for this one, that 8 is going to be right here. So that's going to be helpful because we're trying to get the resultant, or the total distance covered from this way, and this way. In order to do that, we need to break it up into parts so that we can add the straight lines together and add the south to the south to the north, and add the west to the east to get the final resultant. In order to do that, we have to break it up into triangles. So let's do right here. It doesn't really matter where you put them as long as you have triangles. All right. And because this is a right triangle, there's going to be a 90-degree angle right here. And then this is supposed to go here. I don't know why it's so high. And this is supposed to go right here. Okay? So, what we're going to do is we're going to label this A of X. And then we're going to label this A of Y, because this is the X and this is the Y. And then we're going to label this B of X and this B of Y, because this is the X and this is the Y. And then we're going to set up a little graph, because not a graph, a chart, because in the end we're going to want to add this to get the total direction, because you see how it went this way. Well, it also went this way, so we have to see how it cancels out. And then see how this went up, and see how this went up this way too. We have to see how those units add up. So we're gonna get that by doing Pythagorean theorem and also like SOHCAHTOA. Okay, so let's just make a chart. So we're gonna do A, B, X, Y, and then the resultant R. Let's just call it R. Okay. So this would be A of X, B of X, A of Y, and B of Y. Okay. So now, in order to get A of Y, we have to use SOHCAHTOA, so across from the 35-degree angle, which is right here, is A of Y, and the hypotenuse is 15. So we're going to use sine, because opposite hypotenuse is sine. So sine of 35 is equal to A of Y over 15. And then you cross multiply, and you get A of Y is equal to 15 sine 35, which if you put that in the calculator, you're going to get 15 sine 35. A of Y is equal to this big number. Let's just write 8.6. Now we have A of Y, and I'm just gonna do SOHCAHTOA again, but you could also do Pythagorean theorem. No, A of Y is positive.
No, A of X.
And yeah, A of X is going to be negative, because you see how it's on the left. This is technically the third quadrant, or right down here is technically the third quadrant. This is the second quadrant, and because it's on the left, the second and third quadrant are always going to be negative, just like how the first quadrant is always positive. Okay, so the X coordinate is going to be negative. So because of this, we're going to just put a negative here. Anyway, so now when we get A of X, let's do, because A of X is adjacent to 35 and 15 is the hypotenuse, you're going to use cos. So cos of 35 is equal to A of X. And then divided by 15. And you're going to do the same thing and cross multiply, and you're going to get a of x is equal to 15 cos of 35, which is 15 cos 35. Oops. Which is 12.287, big number, whatever. Just do a of x is equal to 12.3.
Isn't it negative 12?
But yeah, it's going to be negative because it's on the left side on the x-axis. So on the left, it's always going to be negative because negative numbers, if you think of like a number line, it's going to be negative. Anyway, so this would be negative 12.3, and this is going to be 8.6. So let's just write that in here. Negative 12.3 and 8.6. Okay, so now we have to do that for b of y and b of x. So we're gonna do the same exact thing. I'm gonna go a little bit faster this time because we're just doing the same exact thing. This time we're gonna use 50, and across from 50 is b of y, and then the hypotenuse is 10. So opposite hypotenuse is sine, so we're gonna do sine 50 equals b of y divided by 10. Cross multiply, you're gonna get 10 sine 50, which is equal to 7.7. And because b of y is positive, because b of y is positive, because it's above the x-axis, it's gonna be positive, not negative. 7.7, I mean. Okay. And now we're gonna do the same thing, but for b of x. So b of x, because it's adjacent to 50, it's gonna be, and this is the hypotenuse, it's gonna be a cos. So cos of 50 is equal to b of x divided by 10. 1. B of x is equal to 10 cos 50. And then b of x is equal to 6.4. And b of x is also positive because it's on the right side of the y-axis. So b of x is 6.4. Now, if you didn't notice something, we actually have 3 vectors here. So you can't just ignore this one. Well, and if you notice that it's going down in a straight line on the y-axis. So that means it is actually like, you don't have to make a triangle for this one because it's already going in perfectly south because it's literally on the y-axis. So this one is just going to be -8. So let's just add a little extra column right here. Just add -8 because we're also going -8 units down. So, and this is just negative because it's going south. So now when we add them, you get -12.3 plus 6.4, which is -5.9. And then that's for your x coordinate. And then when you add these, you get 8.6 plus 7.7 minus 8, which is equal to 8.3. So now you know, well, I'm going positive on the y-axis, and I'm going negative on the x-axis. So that's really important because you're gonna draw your triangle for the resultant, which is gonna kind of look like this here. So we're going negative. That means that the resultant has to, So this is negative. Let me just draw this out first. This is -5.9, and it is going north, 8.4. So let's just draw it here. 8.3, I mean. So because it's negative, the resultant's going in the left direction, because, you know, if it's negative on the x-axis, you're on the left side. And because it's 8.3 is positive, the resultant's going north, which would be up.
Good physics students put arrows.
Good physics students put arrows. Whatever. Anyway, so we know that here is going to go to here because it's going to the left and it's going north. This is your resultant. So technically, your starting point is here because if you remember what Mr. Lella taught us is that you always go head to tail. So you go to the left and then you go there. And then the resultant is this little line right here. In order to get this little line right here, you have to do Pythagorean theorem, which is this plus this. You square everything equals c squared. C squared is equal to, here, just do my calculator. Oops. Oh my god, bro, I'm so bad at math. Holy crap.
You did not just say that.
Dude, I keep screwing out this damn calculator. Oh my god. Oh my god, bro.
You did not just say that, as you're the only one who understands how to do this.
Anyway, this is what you get when you do Pythagorean theorem.
10.2
10.2.
m over s.
Oops. C is equal to 10.2. So this is 10.2. The thing is that you know that this is 10.2 m over s because m over s is the units that we're using, but you don't know how many degrees it's going at. So it could be going 10.2 around any, like around this point, any direction, going 10.2 this way, 10.2 that way, 10.2 this way. But we know that it's going up this way because we literally just observed that it's going negative 5.9 to the left and 8.3 north. So that means it has to be going this way. So we know that we need to specify, and we need to put an angle to go along with it. And it happens to be this angle right here. Because if we're looking, we're starting at the origin, and the angle will always be at the start of the origin. And the origin is right here because I drew it.
Tan.
So in order to find this angle, what we're going to do is we're going to do tan of these two angles. So first what we do is we put tan, and then opposite, because tan is SOHCAHTOA, opposite of it is 8.3. Opposite of the angle is 8.3. And then adjacent of the angle is negative 5.9. And if you know anything about tan, what you have to do with that is you have to tan negative 1 it, 8.3 minus 5.9, and then you can set that equal to the angle. That's just geometry. So what you're gonna do is you're gonna do second tan.
That looks confusing.
What?
You can also just do it like that.
No. And then you have to do 8.3 divided by negative 5.9. The thing is that you're gonna get a negative angle, but the angle right here, if you think about it realistically, is not gonna be negative. It's gonna be positive, so we're just gonna negate the sign. It's gonna be 54.6.
Is that putting negative?
No.
But on the other ones we did.
No, we didn't.
You told me we did.
We literally did not.
I have negatives on the other one.
Bro. Okay. So you're gonna get 54.6 as your angle, because that's what you did. You did tan, -1, blah, blah, blah. Anyway, so now that we have both our distance and the angle, we have to figure out how to write it. So first we're gonna write, my answer's gonna be up here. Just move it down. First we're gonna write 10.2
The right R equals.
meters per second. Yeah, this is what the resultant equals. That was what we were trying to find. And then we know that off the origin, it's going left, which is west, and it's going up, which is north. So we're going 54.6 degrees north of west. And that's your answer. And that's because when you're going first off, you're going west first. So once you go west, now you're going north from west. So north of west. All right, that's it. Bye.